Hi and Assalamualaikum. Today we want to present our Matrices mini project. Okay, firstly we want to introduce ourselves. My name is Muhammad Mikael bin Muhammad Razid, AS10873.
My name is Muhammad Fikri bin Muhammad, AS11028.
My name is Hafiz bin Muhammad Nafi, AS11289.
Where's Haziq?
Hello, my name is Muhammad Haziq bin Rozi. My metric number is AS10940. We are from the group 7.
Okay, the statement that I'm given is I don't want to send a secret message to Musu. So he want to send a make me at noon. Then he transfer it to the matrix which is M. Then he use the encryption step and choose a random matrices. Then he multiply the M and K matrices and get a P. And then Musu use the decryption step, and which is he must inverse the K and multiply the P with P to get the M matrix which is mid at noon. Okay, now the question that we get is I don't want to send a new secret message to Busu. Then he give Busu 3 matrices which is K1, K2 and K3 to Busu find the secret message. Then Busu must multiply the P matrices that have been given in the question with the inverse of the 3 matrices that have been given from Along to get a new secret message. Now, let's do it.
Hello everyone, today I'm going to find the inverse of K1 using adjoint method, then decrypt the message using the inverse. Is it the correct message? We will know later. If the answer is no, then I'm going to explain why not. Firstly, we need to find the determinant, K1. Here is the matrices. As we can see, there is no 0 in any row. So, I'm not going to prioritize any row to make it as the way to find the determinant. Hence, I'm using the first row as the method to find our determinant. This is how we find it. We are going to cut it off, and then we are going to find the AD minus BC. Hence, to find the AD minus BC shape, we are going to close it like this. And then you can see 5 is the upper part. So we are going to use the 5 in multiplying into the AD minus BC. So it will result in this 5 times 10 minus 2. Next we will do the same, but we will shift into this one, 3. And we can see the form of AD minus BC, 1 times 5 and minus 1 times 2. So as the upper part is 3, we are going to do it like this. Negative 3 times 5 minus 2. The reason why it's negative 3 is due to its cofactor. And then the last one is plus 1, 2 times 2 minus 1 times 2. So we can see that it's going to be plus 1, 2, minus 4. And then the answer is going to be 87. We are going to repeat that into every minor. Lastly, to find the determinant, we are going to add all the minor that we found. And then we find the determinant is going to be 16. Next, we have find the determinant. Now we are going to find the inverse of K1. K1 inverse equals to 1 over determinant of K1 times K1 transpose. So it's going to be 1 over K1 determinant, and then we are going to multiply it into the K1 transpose. And now for the K1, we are going to find each minor. From here, minor row 1, column 1, we are going to do negative 1, 1 plus 1. This is because we need to determine whether the position is going to be positive or negative for 3. Hence, once we cut it off, we are going to do this. This is the same as the way we find the determinant. So 5 is going to be the upper part, and then 2 times 5 is going to be 10 minus 1 times 2 equal to 2. So we will shape into 1 times bracket, big bracket, and then 5 times 10 minus 2. And we will do all the same. We will result in, and eventually we will get 29 as our answer for minor 1, 1. We are going to repeat this whole process until we complete all of the minor here. Alright, as we are done finding each minor, we are going to assign them to their respective M11, M12, M13, M14. And here we get the matrices here. And then we are going to transpose them. When we transpose them, it's going to be from this way, going to be this way. And then once we are done transposing them, then we'll find the K1 inverse. To find K1 inverse, we are going to do 1 over K1 determinant multiply into K1 transpose. So it's going to be 1 over 16, as the determinant we got just now is 16, minus the K1 transpose that we got just now. And then the K1 inverse will be like this. As you can see, there is no whole number. The only rational number as fraction is this here. Hence, matrix K1 is undecryptable because of the rational number that exists inside the matrix. To decrypt the message, the value inside the matrix are needed to be whole number. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. So now we want to find the inverse of matrix K2. So firstly, to find the inverse of K2 using the method of elimination row operation, we must to find the determinant to determine that this matrix K2 have an inverse or not. So to find the determinant, we must choose any column or any row to evaluate. So I choose the column 1 to evaluate. So first thing first, when we choose the column 1, we must evaluate it like this. So when we cancel column 1 row 1, we will get a matrix 3 by 3. So this is, and then we find the cofactors of the matrix, which is the positive one. So positive one multiply by 5, and then we times it by the matrix of 3 by 3, which is we get from this 142, 552 and 441. So positive 1 times 5 times the matrix 3 by 3. Same goes as the column 1 row 2, which is negative 1 multiplied by 1, because the cofactors is negative 1, times by the matrix 3 by 3, which is 544, 542, 452 and 441. So and then we do for the row 3, which is 4, positive 1 times 4 times the matrix 3 by 3. And then the last one, the fourth row, which is the 2, and the cofactors is negative 1. So negative 1 multiply 2 times by the matrix 3 by 3, which is 514, 455, 444. So the last equation we get is 5 times by this matrix 3 by 3, negative 1 times this matrix 3 by 3, and 4 and negative 2. So I name this 4 matrix is the A matrix, B matrix, C matrix and D matrix. This is 4 matrix, which is A, B, C and D. That's why we get the answer is 0. So since the matrix, the determinant of this matrix is 0, so we cannot find the inverse. So I can show you, if we use ERO, elimination row operation, we cannot find the inverse. So now this is how we want to find the inverse. So for row 1, I choose to use the operation divide by 5. So one example, 5 divided by 5, you get 1. That's why you get 1. For row 2, the operation is R2 plus negative 1 R1. So one example, 1 plus negative 1, 1. That's why we get 0. So for row 3 is R3 plus negative 4 R1. One example, 4 plus negative 4, 1. That's why we get 0. So for R4 is R4 plus negative 2 R1. One example, 2 plus negative 2, 1. That's why we get 0. So if we use ERO, we cannot find the inverse. So K2 is not the message that Along want to send. Thank you.
To find inverse of K3, I was given option to either use adjoint method or arrow method. I decided to use adjoint method. First of all, the formula to find inverse by adjoint method is 1 over determinant multiplied by transpose of conjunction of the matrix. Determinant of K3 matrix will find by sum of the conjunction of first row matrix, which is 3, 5, 5 and 2. The first row conjunction that I find is 0, 125, negative 75 and negative 30. The sum of this conjunction will be the determinant of the matrix, which is 20. After that, I need to find every single conjunction in the K3 matrix. All the conjunction then be transposed as the formula said so. This is all the conjunction that I find from the formula negative 1 power of row plus column multiplied by all the first 3 row. After find all the conjunction of K3 matrix, I transpose it, then this is the new matrix of transpose of conjunction K3. So to find the n inverse, the formula is 1 per determinant multiplied by conjunction transpose of matrix. So 1 over 20 multiplied by transpose conjunction, I get this matrix. This matrix then will be multiplied by P to get the secret message sent by Along. This new matrix then have been translated by coding method that both Along and Busu agree. So the message is as per head start.
And now we are done with our Matrices mini project. Thank you for watching.